Hey guys, I hope you're having a good day. All right, first page in your packet, radical review. What I've done here is I've just written the first perfect squares from 1, my pen, of course, is feeling a little sleepy, from 1 to 15. I'm going to zoom in a little bit, maybe that'll help. Okay, and 1 times 1 is 1, 2 times 2 is 4, 9 times 9, 3 times 3 is 9. 4 times 4 is 16. Okay, so if the number underneath the radical is not a perfect square, we've got to find the factors that are a perfect square and pull out a square root. So the number underneath the radical must be positive. It cannot be a negative number. All right, those are imaginary numbers, and you will get to those next year. Okay, so let's start with 56. 256 is actually a perfect square. It is 16 times 16, but just to show you how that works, I'm going to just go ahead and draw out my little factors. All right, 16 times 16. And I'm going to do 4 and 4 and 4 and 4. Okay, then over here, I'm going to do 2 and 2. Okay, these can't be factored anymore, right? And here, I'm going to do 2 and 2. Over here, 2 and 2 and 2 and 2. Okay, so what you want to do, as I dig through the pens, I feel like those makeup artists on YouTube. I won't be giving you any tips on how to do makeup, though. Is circle the two pairs. So it needs a buddy, right? It needs a buddy in order to be a pair. All right, and then what you think is if it has a pair, it becomes 2, and then we've used that pair, and we have this other pair, which becomes this other 2, and now we have this third pair, which becomes that 2, and this fourth pair, which becomes that 2. So 2 times 2 times 2 times 2 is 16. Okay, so that's a very long, drawn-out way if you didn't know that that was a perfect square. All right, moving along, let's say we have 72. All right, a lot of you are thinking 9 times 8 is 72, which is great. So I take my 9 and my 8, and I'm going to break it apart. So 3 times 3 is 9. Well, 3 is prime, so we can't go any further. And then I have 8, which is 2 and 4. So 2 and 2. Okay, well, here's a pair, here's a pair. And right here, that's just a lonely guy that was factored to its end, but it can't factor anymore. So what we're going to do is we're going to draw a radical house, and anybody that has a buddy gets to go outside of it. So 2 and 3. They have a friend to play with, so they get to go outside. This poor little 2 has to stay indoors because he doesn't have a friend to go play with. These two have so much fun that they multiply, and our answer is 6 rad 2. Okay, so I want you guys to try number 3. So freeze me and try number 3. All right, and then I'm going to jump down here now to this one because look, there's a number outside the radical. So I'm going to think of my factors for 108, and you guys can guess and check if you don't know them. That's completely fine. I'm going to have 36 and 3. Okay, so 36, I know 6 times 6 equals 36. It's kind of a perfect square itself, right? And some of you that are catching on and thinking, oh wait, Mrs. Black, you could have just done, I know. Okay, so I have my 6's that I broke apart, and 3 can't really go any further, right? So these 3's get grouped together, and these 2's get grouped together. So when we think of our little radical house, I have the 3 that is already out there, right? This 3 comes down. And then I have my pair of 3's that gets to come out of the radical house, and my pair of 2's that gets to come out of the radical house. And this poor little 3 that was a loner, he has to stay in. So then we just multiply them across. 3 times 3 is 9, times 2 is 18. So 18 rad 3 would be your answer. Okay, let's try number 6 together, and you guys need to do number 5. All right, so we're going to break this apart. We're going to do 4 and 5. Well, 5's prime, so it's done. And 4 is 2 and 2. Okay, so that's a pair. All right, well, we look right here, and we already have a 2 out. So I'm going to bring this pair of 2's out. And that poor 5 was the loner, so he has to stay in. Well, 2 times 2 is 4, so our answer is 4 rad 5. Okay, moving on to operations with radicals. When adding and subtracting the radicals, treat them like similar to variables. They can be only combined if they're like terms, meaning like they have the same radical. So when multiplying radicals, if they are the same number underneath, then answer is the same number underneath. If there is a number outside of the radical and a number underneath, multiply the outside ones together and then the ones underneath together. When dividing radicals, you can never have a radical in the denominator. This is so important. Oops, but you can't read. So you need to rationalize it. You multiply the top and bottom radical in the denominator in order to make the bottom clear of all radicals. Okay, so what is she talking about? Well, let's flip our page. Okay, here, notice these are like terms, right? These are the same. So I can go ahead and I can just combine them like I would if they were a variable. So 2 plus 4 is 6, and then my radical stays the same. That's my answer. All right, moving along here, oh shoot, I need to simplify. So I'm going to break this apart, and I'm going to do 4 and 3. Which will be 2 and 2. And that 3 is all by itself. Okay, so what's going to happen is I'm going to have my 6 on the outside times that 2, right? And then that 3 that was left over. So the 6, this guy just came down, and my 2's are right here. So I'm going to be left with 12 rad 3, and now look, my terms are alike. Now I have a 3 here and a 3 here, so I'm going to add it to 3 rad 3 and have 15 rad 3. You guys definitely should have learned this last year, so hopefully I'm not being too confusing. Okay, so this one is super fun, and you guys always kind of get a little mixed up here, but you can multiply them, right? It's the same radical times the same radical, which is always going to be the number underneath. But watch how that works. So rad 3 times rad 3 is rad 9. Well, the square root of 9 is simply 3, so see how it just ends up being the number underneath when it's the same radical? Okay, I want you guys to do number 10 and what other one should you do? 11 and 12. Okay, I'm going to jump down here, so don't worry about doing these, but I'm going to jump down here to number 19. Okay, so I can never have a radical on the bottom. That is not okay. So in order to get rid of it, I have to multiply both the top and the bottom by that radical. Well, 3 times 2, 3 times rad 2 is simply 3 rad 2. And remember, rad 2 times rad 2, well, it's just the same thing, which is rad 4, but then the square root of 4 is simply 2. So remember, the same radical times the same radical is just whatever the number is underneath. Okay, let's look at number 20. I only have to multiply by the rad 3. So times rad 3 times rad 3, I'm left with 5 rad 3 over 2 rad 9. But what's the square root of 9? Ah, it's 3. So 5 rad 3 over 2 times 3, which is 6. So your answer is 5 rad 3 over 6. Okay, let's try this one. Rad 5. So we've got to clear that radical. Remember, rad 5 times rad 5 is simply 5. But if you don't believe me, we'll just write it as rad 25. That's a 2. And then 5 times rad 25. Well, let's start taking the square root here. So the square root of 25 is 5. 5 times 5, because I took the square root of 25, that's where this 5 came from. And I'm left with 5 over 25. But that can reduce, right? They're both divisible by 5. So my answer is 1/5. Okay, let's try this one together, and then you guys have to do number 22 and 24. All right, so I'm going to multiply both the top and the bottom by rad 3. I'm going to get rad 36 over 2 rad 9. Hopefully you see that those are both perfect squares. So I'm going to have 6 over 2 times 3, which 6 over 6, and I just end up with 1. All right, guys, that's it. Have any questions for me, let me know.